Hello, class. Today we're going to be talking about right triangle trigonometry. So here I have written down a right triangle, and on the left I have all of the trigonometric functions that we're going to be talking about today. So the key point in any discussion about right triangle trigonometry is that you have three lengths of the triangle. This length is going to be the hypotenuse, and the opposite and adjacent sides of this triangle are going to be dependent on this angle right here. This theta is going to demarcate which side is opposite and which side is adjacent. So whichever side is the opposite of the theta is going to be called the opposite side. And the side that is adjacent but not the hypotenuse is going to be the adjacent side. So I've written down SOHCAHTOA, and this is just a way of remembering which sides belong to which function. So sine, so, is going to be opposite over hypotenuse. Cosine, ca, is going to be adjacent over hypotenuse. And tangent, toa, is going to be opposite over adjacent. Now, we don't have I guess, a phrasing for cosecant, secant, and tangent, but these are just going to be the reciprocals of our original trig functions. So cosecant is going to be the reciprocal of sine, secant is going to be the reciprocal of cosecant, and tangent, oh, I wrote tangent twice. This is cotangent. Cotangent is going to be the reciprocal of tangent. And this reciprocal rule is something I'll go over later in class, or later in a lecture video. But for now, this is all I'm going to say about the trigonometric functions. These should be studied to the point of memorization, but this phrasing, SOHCAHTOA, is an easy way to help the memorization process. For now, I'm going to show you an example. Given some values of this triangle, how can we find all of the trigonometric functions? Okay, here's an example of a triangle you may encounter. And we want to try to figure out what sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta all are. So the first thing that we have to do is recognize that we do not have all sides of this triangle. And I want you to pause the video to see if you can figure out how you can solve for this side of the triangle. Okay, hopefully you paused the video and found out that the way that you solve for this side is through the Pythagorean theorem. So we can call this side B. We can square R2, square R5, and then subtract the 25 from 4 right here. And then we get B is equal to square root of 21. So we can erase this side right here, replace that with square root of 21. And now that we've solved for all three sides of our triangle, we can use SOHCAHTOA as a way of finding all of the values of our trigonometric functions. So sine theta is going to be opposite over hypotenuse, which is square root of 21 over 5. Cosine is adjacent over hypotenuse, so that's going to be 2 over 5. And tangent is going to be square root of 21 over 2. Cosecant is hypotenuse over opposite, so that's 5 over square root of 21. Secant theta is hypotenuse over adjacent, so that's going to be 5 over 2. And cotangent theta is going to be 2 over square root of 21. And I hope that in this example you see why I mentioned that these are the reciprocal of our original three trig functions, because these fractions right here are obviously the reciprocal of one another if we take tangent theta times cotangent theta. This would simply be square root of 21 over 2 times times 2 over square root of 21, which is equal to 1. So this is why I mentioned the reciprocal rule. And we'll go over that in the next video when we talk about other trig functions and their identities, as well as the special right triangles and how they apply to our trig functions. Okay, but that's it for today. See you next time.